Okay, welcome back to a continuation of the chi-square analysis. In this lesson, we are going to be taking practical examples on how to run each specific type of chi-square test that we talked about in our previous video. So in this example, we are going to start off by talking about the chi-square goodness of fit test. The chi-square goodness of fit test. So we'll be trying to see how we can run the chi-square goodness of fit test in SPSS. It's very easy, very simple. Okay, let's get into it. So this is SPSS. And this is our data that we are going to be using here. So you have our data and ID, date of birth, today's date, the latest making full name, the gender, siblings, more affiliation, and so on and so forth. Now, remember in our previous video, we said in order to run the chi-square goodness of fit test, we would have to compare one variable. Let me bring it up. Remember, we said to run our chi-square goodness of fit test, we have to run one variable with a theory. So the example we are going to be using in this video, we are going to say that we expect that the number of students who are in this particular study will choose the same, will be equally distributed in each of the hall of residence. So this is the hall of residence. And then in our test, we are expecting that the number of students in each hall of residence is going to be equally distributed. Equally distributed. So this theory or this assumption is what we are going to test. And in order for us to test this, we would have to use the chi-square goodness of fit. So again, the question is, test whether the theory, that is, are the number of students in the study equally distributed in the hall of residence, true or false? So that is the theory we are testing today. Now, in order to test for this theory, we said we are going to use what? The chi-square goodness of fit test. The chi-square goodness of fit test. Now, this data here is a non-parametric distribution. It's a non-parametric distribution. Please, if you want to know what's parametric and non-parametric, sorry for that glitch. If you want to know what parametric and non-parametric distributions are, please refer to our previous videos on the types of data. Moving on. So this data set here is a non-parametric distribution. So in order to run our chi-square goodness of fit test, we first go to analyze. Then from analyze, we come down to non-parametric tests. Non-parametric tests. Then from non-parametric tests, we move to legacy dialogues. Legacy dialogues. So we first go to analyze, then non-parametric tests, then we move to legacy dialogues. Now, from legacy dialogues, we then select our chi-square test here. Chi-square test here. So remember, we first move to analyze, non-parametric tests, legacy dialogues, and then chi-square test. So we click on our chi-square test, and then this pop-up menu appears. So let me reset everything. Now, our test variable here is going to be the Hall of affiliation, because remember, we said we wanted to test whether the students are what equally distributed among each of the halls. So our test variable here is the Hall of affiliation. So we select all affiliation here, and then we move it to our test variable list. Now, after we are done with this, we come to expected values here. The expected values here. Then we make sure we tick all categories equal. Remember, because our theory is that all the students in the data are what? Equally distributed across each of the halls. So we take all categories equal. Assuming our assumption was different, that there's a certain percentage of values that each student is what attributed to, then we can use the values here. But that is not what we are doing in this example today. So in this example, we are just testing all categories equal, meaning that we are assuming or we are expecting that each of the students are going to be equally distributed for the or within the hall affiliations. So once we do this, then we move to OK, and then we click OK. SPSS is automatically going to generate everything for us. It's going to do the analysis and generate everything for us. So this right here is our output data. This right here is our output data. So let's explain what we are getting from this output. Now, we see here, which is a summary of all the observed values and then the expected values, which we talked about in our previous video. Then we come to our next table where we have our test statistics. We can see the chi-square test here, the degree of freedom here, and then the p-value on the asymptomatic significance. So we see everything here. So chi-square has simply generated everything for us. Good. So now let's interpret our output data. Now, from this table, we can see that we have 1, 2, 3, 4, 5. 5 different halls. 5 different halls. So what was observed in each hall? What was the distribution of students in each hall? And that we can get it in our observed value. So we can see that in this Independence Hall, we had 24 students there. In Queen's Hall, we had 34 students. In Republic Hall, we had 25 students. In Unity Hall, we had 63 students. And then in University Hall, we had 26 students. But we were expecting that all the students would have been what? Equally distributed or shared among all these 5 halls. So our expected value, we were expecting that each hall will have at least 34.4 students in each hall. So we were expecting that at least each hall will have a total of 34 students. So this is our expected value here. So we're expecting each hall having 34 students at least. But then we observed that the halls had this number of students here. Good. Now this residual is trying to tell us that there is a difference between what we expected and then what we actually observed. That's what this residual here is telling us. So it's telling us that in this hall, we're expecting 34.4, and then we actually observed 24. So the difference between that is negative 10.4. Negative 10.4. Meaning that we were expecting more students to be in Unity Hall as compared to what we observed. So this negative sign is telling us that we had a lesser amount of students in this hall than what we expected. We had a lesser amount of students in this hall than what we expected. That's what the residual in this hall is trying to tell us. The same goes for Queen's Hall. So we can see that in Queen's Hall, we expected 34.4, but we ended up observing only 34. So there's a residual of negative 0.4, meaning that we had less amount of students going into this hall, into Queen's Hall, than what we actually expected. The same goes for Republic Hall. We have a residual of negative 9.4, which means that less amount of students entered into Republic Hall than what was expected. But the story is different for Unity Hall. So we see that in Unity Hall, we had a residual of 28.6, meaning that we had more number of students entering into Unity Hall than what we expected. So we had more number of students entering into Unity Hall than what we expected. And then finally, University Hall, we can see we had less number of students entering into University Hall than what we expected. So the total number of students here is 172. 172. So this is what our first table is telling us. Now let's come to our second table, which is the test statistics. Now, in our second table, it's giving us the chi-square value, the degree of freedom, and then the p-value. Now, the chi-square value here is agreeing with the p-value, which is saying that it is less than what? 0.01, meaning that our chi-square value is what? Large. And remember from our previous video, we said that if the chi-square value is large, or if the p-value is less than 0.05, then it means that the test that we have run is significant. The test that we have run is what? Significant. So what it's trying to tell us, or what this chi-square is trying to tell us, is that there is a significant difference between the number of students that entered each hall. That is what this chi-square of goodness of faith is trying to tell us. It's trying to tell us that there's a significant difference with the number of students that entered what? Each hall. That is what the whole thing is telling us. And then how do we do that? We looked at our chi-square value and then our p-value. Because the p-value was less than 0.05, we concluded that there's a significant difference between the number of students that entered each hall. Good. Now, this DF represents the degree of freedom. What the degree of freedom does is that it tells us the number of categories that was tested. The degree of freedom tells us the number of categories that was tested. Now, if you look here, we can see 1, 2, 3, 4, 5. We can see 5 categories, but the degree of freedom is telling us that there are only 4 categories. What does this mean? Now, in order to calculate degree of freedom for goodness of faith, the formula is the total number of categories, or the total number of test categories minus 1. the total number of test categories minus 1. So if we add the number of categories we have, that is the number of halls we have 5 halls. If we subtract 1 from it, then we get 4. That's why the degree of freedom is 4. So what does this imply? This implies that if we should add the values and observed values for 4 of our halls, if you add 4 observed values for our halls, we are automatically going to get the value or the observed value for the 5th hall, because our total number of students in the study was 172. So the degree of freedom is telling us that if we should add 4 observed values of each hall and then subtract it from our total number of students, we are automatically going to generate the number of students who entered the last hall. So that's what the degree of freedom is going to tell us. So, in summary, the chi-square goodness of fit test was trying to determine whether there was a significant difference between the number of students that entered each hall. And our hypothesis was that all the students are going to be equally distributed amongst the halls. But after we ran our chi-square test told us that because the p-value was less than 0.05, then it means that what we expected was wrong, but rather we had a significant difference with the number of people or the number of students that entered each hall. Very simple, very easy. So that's what the chi-square goodness of fit is trying to tell us. It's very simple, very easy. So, in summary, we learned how to run the chi-square goodness of fit, and then how we'll be able to determine whether the test is significant or not. Very simple, very good. In our next example, we are going to move on and talk about the chi-square test of independence. The chi-square test of independence. See you in the next one.